Hello and welcome to the point cloud training module. In this session we will see how you can start from a point cloud, model a bit towards the point cloud, how you can crop the point cloud and how you can import it. And also we will see a finished result of a church that was modeled after a point cloud, of which I can show you the point cloud, but I can't give it to you because it's only for demo material and not for training material. So I will start by opening the starter files. So go to your training files and go to the starter files of the point clouds, and then open point clouds. I will work in the BIM workspace, but you could also work with point clouds from platinum level onwards. So it's not necessary to have BIM for this. So the first thing I will do is I will attach a point cloud. I do that by going to the Insert tab and clicking on Attach Point Cloud. The unit system of this drawing is meters, so I will import point cloud as meters. So I attach the point cloud and I choose from file. You can also import from an entire folder. And then the supported formats are .les, .pts, .ptx, .rcp, .rcs, and the legacy file format .bpt. So V19 used to have this internal point cloud format of .bpt, which we won't support anymore since we are now working with the .vrm format. Instead, it's an internal format. It's not from an external source, but it's how we process the point cloud data behind the scenes. And the supported file formats, they will we will get more in the future, but for now, these are the supported formats. In the starter files, you will find a .ptx file. You can double click it to open and it will ask you the unit for point coordinates. I will enter E for meters. It will start pre-processing the point cloud. You will see it in the bottom of your screen, and the attach point cloud pop-up will pop up and it will ask you where you want to insert it. I want to insert it on 0, 0, so I don't specify on, I just specify on screen, I check off the scaling, I check off the rotation, and I click OK. And you see now immediately it shows up because I was a bit slow and it's kind of already was processed before I wanted to view my format. So if you would be faster than me, and then you would be able to do region, and you would see the point clouds anyhow because you regenerate your model space. And you see that it only took 13 seconds to load because it was not such a big point cloud. So you can change the point cloud's point size by going to the point clouds tab and increasing the point size. Then you will see that you kind of get a smoother image. If you decrease the point size, you will see them more like pixels instead of as dots. So I like to keep it on this. You also may notice that it's adaptive. So if I zoom in, some parts have bigger pixels than others. That is because where the points are shallow, where there are not so many points, it will display bigger than in other parts. This is a setting. You have point cloud settings, and there you can find the point cloud toggle adaptive versus fixed point size. Now I use adaptive point size. If I use fixed point size, all my points will have the same size. So no matter if there are a lot of points or not so many points, it will use this fixed point size. I like to keep it on adaptive because it gives you a smoother preview, but I can show you if I use fixed point size what it does. Then if I regenerate, you will see that now if I zoom in, you see the pixels really as the points really as pixels. Also, when you are rotating or orbiting, they are really as pixels, and then they kind of render in a way that they all have the same pixel size. So I go back to settings and I use my adaptive point size again, and then I do region, and it will also, in the shallow parts, it will give me a better preview. Then we have a setting called point cloud point max. This is the amount of points that you see on your screen. So if I'm zoomed into a certain level, now I will see a maximum, because it's a maximum. If there are not so many points, they won't show up, of course, but a maximum of 4 million points. I can give in a new value, for example, 500,000. And then you will see the points get bigger because, as I say, if they are shallow, they will display bigger. So that's why they get bigger. But in essence, we have less points on our screen right now, and also the orbiting will go even faster. So if you would have a very, very, very large point clouds and you don't have a very powerful machine, you might want to set it on to only 500,000 points that you can see at the same time. So, but for me, 4 million is a great value, because if you see point cloud point max, if I put it onto 4 million, you will see 4 million points on your screen, and I think it's a very good performance for my system. So it will always show you 4 million points. Unless you are orbiting, then it will show you a bit less points. But if you stand still for a moment, it will kind of render itself until you see 4 million points. So also, if I would make a section box around one part of my drawing, this would be only 4 million points inside the section box. So that's what I now will do. I want to isolate this part of the pump. And for that, I will make a detail section. So you see that my UCS is currently not rotated as I want, but I am able to snap to the points of my point cloud. So I can snap till here, and then I can give in a height like this. So I can choose already a box, but the box is oriented in my XY plane, because that's the orientation, and the point cloud is rotated along another axis. So you could rotate your point cloud, but that's not what I want to do. I will rotate my section box instead. So I long click my section box and I pop up the manipulator, and then I will orient it that it's almost parallel to my pump, and I will move it a bit so that I only see my pump. So I only want to see that part of my pump. So now I would see only that part if I clip my point cloud. If you move and orbit your section box, make sure that you only have selected your section box and not your point cloud as well, or you will move your point cloud, which is not what you want probably. So if you now clip the section from the quad, you will only see this part of the pump, which is nice because it's this part that I want to model. If you would like to, you can still adjust your grips, and then you can see even when it's clipped, it will show you only these maximum of 4 million points, and it will kind of automatically adapt to the size of your section box. So it will also clip and preview your points. And then I want to rotate my UCS so that it's aligned with my section box. So I type in UCS and I specify as origin point, I specify the end point of my section box, which is now a bit hard to select because I have all these points, but if I do it like this, I can still select my endpoint of my section plane. And then to the other end, I want as well my section box, so the x-axis along my section plane, and the y-axis I want to point where now I have my z-axis, so I point it upwards by holding down Shift in ortho mode. And then you see it's oriented like this. So if I now start to draw a primitive, a cylinder, I will start to draw in this plane, so because it's in the XY plane that I'm now drawing. So I now want to measure the diameter of this pump, so I will launch the distance command, and I will snap to one of the side points, and then go straight, so hold down ortho, and I see it's 0.8, so my diameter is 0.8 meters, and I will make a radius of 0.4. So I launch the cylinder command again, and I start somewhere in the middle, so I choose one of the points here to to start the cylinder command as a center point, and I give in the radius of 0.4. And then I can choose a length, and I can choose it based on my point cloud, and then I can still pull the side of my pump until it's at the desired location. So this is how I model my pump based on the point cloud. It's not very precise, but you probably want a new pump in this location anyhow, so you will make some small adjustments and just model it what you want on this location instead of model entirely according to the point cloud. So this is how you can show the point cloud together with the 3D model. And if I now unclip my section, you will see that it shows the pump together with my cylinder. And if I go to back orientation, this will actually be what used to be the front, the top view. And if I put my perspective mode off, I will be able to see precisely on top of my pump. So if I first select my point cloud and I choose crop, it will ask me to select the first corner point for my crop, and then a next one. So this will now make a virtual extrusion of this shape, and will crop everything inside or outside this shape. So what do I want to see? I want to see the outside of my of this shape. So I choose O and I press enter, and then you can see, if you now put it back to perspective on, you can see that the pump in its context actually. So that's pretty cool. If you want to do the inverse of a section box, you can use crop and crop the outside, so showing only the outside of what you cropped. And if you now hit uncrop all, the crop will be gone again. So that's pretty convenient. I will just show you how you can model a church after a point cloud. So you can go to your training files, to the starter files, to the point cloud files, and open the church. And then you can see a model of a church. As I said, I couldn't provide you with the point cloud, but I can show you now how it looks with the point cloud attached to it. By typing in point cloud reference, I can load in an already pre-processed point cloud, and I enter it on 000 again, and then you can see the point cloud together with the model. And then you can see it's looking pretty nice. And I can show you the same things that I did onto the onto the pump before. So I will crop out the inside of where I modeled. So I use the crop command and I draw a rectangle over the place where I made my model, and I choose outside to only show the outside, and then you can see the church, the model church in its context, which is a pretty nice thing you can do with the crop command. But I will uncrop now and I will show you how you can also, how I started with modeling this point cloud model. So I just modeled a section box around the point cloud, and I gave it a height of 1, and now I can clip this section. If I select it, I can clip display it, and then you can see a sort of a plan view exists or is defined. If I hide a wall, for example, you can see how the point cloud defines some sort of outline, and you can see the interior of the church as well, because we now have a slice at the ground level. And then I just, with the polysolid command, I modeled over this, and then with the push-pull command, I push-pulled the height of the solids to the needed height, and then with some direct modeling, I modeled the entire church. If you want a detailed overview of how I did it, you can always go to the blog, because soon a blog post will arrive at how I modeled this church based on the point cloud. So that was it for the point cloud training. I hope you enjoyed it, and feel free to check out the other modules as well. Bye.